You think empty space is nothing, a background, a gap between real things. You imagine it as silence, as absence, as what's left over when matter leaves the room. You picture atoms floating in a void, and beyond them just more void, clean, passive, harmless. You think physics agrees with you. That equation start after space is already there. That space itself doesn't do anything. This is wrong. You were taught to ignore empty space, to treat it as a stage, not a participant, a container, not a character. But one equation quietly refused to cooperate, not loudly, not dramatically. It simply wouldn't work unless empty space stopped being empty, not metaphorically, literally. And the man who noticed this didn't call it strange. He called it unavoidable. You've been standing on something you were told wasn't there. And it has consequences you've never been shown. Physics usually feels cooperative. You write down an equation. If it disagrees with reality, you adjust it. You add a term. You remove an assumption. Reality wins. That's how it normally works. But in the late 1920s, Paul Dirac wrote down an equation that did something unusual. It didn't argue. It didn't negotiate. It simply refused to make sense unless reality itself changed. Dirac wasn't trying to discover anything radical. He wasn't chasing metaphysics. He was doing something boring and technical, fixing a mismatch. Quantum mechanics worked. Special relativity worked. But they didn't work together. Electrons were quantum objects. They were also relativistic objects. No equation at the time respected both facts simultaneously. So Dirac did what a careful physicist does. He demanded consistency. The equation he wrote was elegant, compact, almost suspiciously clean, and immediately it broke physics, not experimentally, conceptually. When Dirac solved his equation, it didn't give one answer. It gave two. For every electron state with positive energy, there was a corresponding state with negative energy. This wasn't a small correction. It wasn't an approximation error. It was exact. The mathematics wasn't confused, it was precise. Physics, on the other hand, was not prepared. Negative energy wasn't just unfamiliar, it was catastrophic. If such states existed, electrons should fall into them instantly. There would be no stable matter, no atoms. No chemistry, no you. Reality clearly hadn't collapsed. So the standard instinct kicked in, the equation must be wrong. But here's the problem. Every attempt to fix the equation destroyed something else. Remove the negative solutions, and you break relativity, tweak the structure, and quantum mechanics fails. The equation was internally consistent, painfully so. Dirac noticed something unsettling. The equation wasn't misbehaving. Your expectations were. You expected equations to politely describe the world you already believed in. This one didn't. It imposed a condition instead. Either nature allows negative energy states, or your picture of empty space is incomplete. Dirac chose the second option, not because it was comfortable, because it was the only one that worked. He didn't yet explain how empty space had to change. He didn't dress it up philosophically. He simply accepted the implication. The equation wasn't asking permission. It was setting terms. And physics reluctantly had to listen. You were taught a quiet rule, so quiet it feels like common sense. Energy has a bottom. There is the lowest possible value. You can lose energy, but only so much. This belief isn't philosophical, it's practical. If energy had no lower bound, nothing would ever stay put. Everything would keep falling forever. Dirac's equation ignored this rule. It didn't suggest slightly lower energies. It opened a trapdoor. Below every allowed energy state, there was another and another and another. No floor, no bottom. If electrons could access those states, they would. Instantly, not slowly, not probabilistically, they would dump energy endlessly. Atoms would collapse. Radiation would explode outward. The universe would tear itself apart before it could begin. And yet, here we are. So physics tried to do what it always does when something dangerous appears. It tried to declare it unphysical. These states aren't real. They're just mathematical artifacts. Ignore them. This move usually works. It didn't work here because the negative energy solutions weren't optional. They weren't decorative. They were woven into the structure of the equation itself. Removing them didn't simplify the theory. It mutilated it. Relativity demands symmetry between space and time. Quantum mechanics demands linearity and completeness. Dirac's equations satisfied both. The negative energies were not a glitch. They were the cause. At this point, the problem stopped being technical. It became existential. If negative energy states exist, matter is unstable. If they don't exist, the equation is wrong. If the equation is wrong, then our most trusted principles don't fit together. Something had to give. Dirac realized the mistake wasn't assuming negative energy was impossible. The mistake with assuming empty space was simple. You imagined a vacuum as neutral ground, a place where nothing happens unless something enters. But the equation was hinting at something else. If electrons don't fall into negative energy states, then something must already be preventing them. Not a force, not a barrier, a condition. Empty space itself could not be empty. Not in the way you thought. Dirac didn't yet say what space contained. He only recognized what it couldn't be. It could not be an open abyss of available state, because if it were, reality would not be stable. So the question shifted. Not why don't electrons fall, but what are they falling into that's already full? At this point, the situation was no longer subtle. It was dangerous. Dirac's equation wasn't hinting at a curiosity. It was predicting a disaster. If empty space truly contained nothing, then negative energy states were vacant, available, inviting. An electron wouldn't hesitate. It wouldn't need encouragement. It would simply drop from positive energy to negative, from stability to collapse. And once it started, it wouldn't stop. There was no lowest state to settle into, only endless descent. Each fall would release energy, real energy, radiation. Matter wouldn't slowly decay. It would detonate continuously. This wasn't a philosophical worry. It was a fatal one. A single electron in an empty vacuum would be enough to end the universe. And yet, the universe looked stubbornly intact. So physics faced a brutal contradiction. The equation is correct. Empty space exists. Matter is stable. All three cannot be true at the same time. Something had to be false. Most people instinctively choose the equation. It feels safer to blame mathematics. Dirac didn't. He trusted the structure more than the intuition. The equation wasn't chaotic. It wasn't pathological. It was too precise, which meant the problem wasn't the prediction. It was the assumption that made the prediction lethal. The assumption that nothing occupies negative energy states. Here's the move that made physicists uncomfortable. What if all those negative energy states were already filled? Not metaphorically, not approximately, completely. Imagine a landscape of infinite depth. Every lower level already occupied. No vacancies. No room to fall. An electron above cannot drop, not because it's forbidden, but because there's nowhere to go. This wasn't a mechanism. It was a redefinition. Empty space wasn't empty anymore. It was saturated. A background so full it appeared invisible. This idea didn't make space crowded in the usual sense. It made it locked. The vacuum became a structure, not an absence. A condition that stabilizes matter without exerting force. Dirac didn't celebrate this solution. He tolerated it. Because once you accept it, the catastrophe disappears instantly. Electrons stay where they are. Atoms survive. Reality continues. But the cost is high. You no longer get to think of nothing as simple. You no longer get to think of space as neutral. The most dangerous prediction in physics wasn't avoided. It was absorbed by changing what empty space means. This is where intuition finally breaks. You are used to thinking in terms of objects, particles, fields, things you can point to. Dirac's move didn't add a new thing, it removed an assumption. He proposed that every negative energy state was already occupied, not by observable particles, not by matter you could touch, by something you never see at all. A sea, not metaphorical, literal in the mathematics. An infinite collection of electrons filling all negative energy levels, perfectly uniform, perfectly invisible. This wasn't because they were hidden. It was because nothing distinguished one from another. Uniformity erases observability. You don't notice air pressure when it's the same everywhere. You only notice differences. Dirac's vacuum worked the same way. If every negative energy state is filled, no electron can fall into them. Stability is restored. But something stranger happens. If you remove one of those filled states, not all, just one, you don't see nothing. You see a particle, a hole. A missing negative energy electron behaves like a real positive energy object. It responds to fields. It carries mass. It carries charge. Opposite charge. This wasn't a poetic interpretation. It dropped directly out of the equation. Antimatter wasn't introduced as a new entity. It leaked out of the vacuum as a bookkeeping necessity. The shock here is subtle. The vacuum wasn't empty waiting to host particles. Particles emerged as disturbances within the vacuum structure. Matter became secondary. Space became primary. This flipped the hierarchy you were taught. You thought space existed because matter needed somewhere to go. Dirac showed that matter exists because space has a structure that allows deviations. And this structure wasn't optional. Remove it, and the equation collapses. Ignore it, and stability vanishes. Dirac didn't know if this sea was physically real. Even he was uneasy. Later physics would reinterpret it, refine it, replace the picture, but not the conclusion. Empty space cannot be treated as empty, not without breaking the rules that keep reality intact. The sea itself may not survive in modern language, but the need for a non-trivial vacuum does. You are not floating in nothing. You are embedded in a condition that makes existence possible, and you never notice it because noticing would require it to be absent. It's tempting to stop here, to declare victory. Dirac predicted antimatter. Experiment confirmed it. Case closed. This is the version you were told, but this framing hides the real disruption. Antimatter was not the goal. It wasn't even the insight. It was debris. The core problem was never what new particle exists. It was why doesn't reality collapse? Antimatter appeared only after the vacuum was redefined, only after empty space was forced to carry structure. The whole came first. The particle came later. This reverses the story. You imagine discoveries as additions to the world. A new thing is found. Reality grows. Dirac's discovery was subtractive. He removed emptiness. Once you do that, antimatter becomes unavoidable, not mysterious, not exotic. It is simply what a vacuum disturbance looks like when charge reverses. This is why antimatter feels strange. It wasn't designed to exist on its own. It exists as a complement, a reflection of what happens when the background shifts. And here is the deeper discomfort. If antimatter is just a hole in a filled vacuum, then the vacuum must be more fundamental than particles. Particles are excitations. Vacuum is the baseline. This means asking why does antimatter exist is the wrong question. The correct question is, what does empty space allow to be missing? Modern physics no longer talks about Dirac's sea literally. The picture was too crude, too classical. But the lessons survived the replacement. Quantum field theory did not eliminate the structured vacuum. It made it unavoidable. The vacuum now sees with fluctuations. Fields never switch off. Zero point energies remain. Even when no particles are present, the vacuum still does work. Casimir forces, Lamb shifts, measurable effects, not as leftovers, as features. Antimatter was the first crack in the old intuition, not the final revelation. Dirac didn't discover a mirror world. He discovered that nothing was already busy. And once you accept that, you stop thinking of particles as primary. They are not residents of space. They are events within it. If empty space is so active, why does it feel so quiet? This is where intuition tries to recover. It wants reassurance. It wants a handle. There isn't one. You don't notice the vacuum for the same reason you don't notice gravity's absolute value. You only feel changes. A uniform background does nothing locally. Not because it's weak, because it's everywhere. Dirac's C and its modern descendants don't push on you. They define the reference level from which pushing becomes meaningful. Think about pressure at the bottom of the ocean. Every direction is saturated. Nothing moves unless a gradient appears. The vacuum is like that, but without a surface. Its structure is not a substance you swim through. It is a condition that all particles already satisfy. Remove one element and something happens. Add one and something happens. But as long as it remains uniform, it disappears from experience. This is why you never see electrons colliding with the vacuum. They are not interacting with it. They are defined by it. The vacuum sets the zero of energy, the baseline of charge, the stability of matter. Change the vacuum, and you change what particles are allowed to be. This is not hypothetical. In extreme environments near black holes inside intense fields, at the earliest moments of the universe, the vacuum behaves differently. Particles appear. Forces shift. Symmetries break. Not because something was added, because the background changed. Dirac's insight quietly prepared physics for this. He didn't know where it would lead. He didn't claim completeness. But he broke the habit of treating space as passive. You are not failing to perceive something subtle. There is nothing to perceive. The vacuum is not an object. It is the rule book. And rules are invisible until they change. At some point, you have to stop calling this a background. A background supports action. It does not cause it. But once you accept what Dirac forced physics to accept, that distinction collapses. The vacuum is not a stage where particles perform. It is the system that decides which performances are even possible. Particles don't move freely and then interact with space. Their allowed motions are carved out by space. This is why adding a particle is not a simple act. You are not placing a marble into an empty box. You are disturbing a configuration that already exists everywhere. The vacuum resists certain changes and allows others, not through force, through permission. This is why conservation laws exist. Not because nature is polite, because the vacuum structure forbids violations. This is why charges come in discrete units, why masses take specific values, why symmetries matter. They are not properties of particles. They are constraints imposed by the ground state of space itself. You were taught that fields live in space. Quantum theory quietly reverses this. Space is what remains when fields reach their lowest possible activity. Particles are excitations above that floor. This is not metaphor. This is how calculations are done. Change the vacuum expectation value of a field, and particles acquire mass. Break a symmetry of the vacuum, and forces differentiate. The Higgs field is not special because it exists. It is special because the vacuum does something with it. Dirac's original C was clumsy. It used particles where fields were needed, but it pointed in the right direction. Empty space is not empty because nothing is happening. It is empty because everything that can happen is already accounted for. The vacuum does not sit beneath reality. It enforces reality. You are not watching physics occur on a neutral canvas. You are watching the vacuum maintain its conditions. And every particle you observe is a temporary violation that the vacuum permits and then corrects